Moving right along to multiplying two binomials. Each of these is a binomial because it's a polynomial, just 1, 2, and 1, 2 terms. Anytime that we are multiplying two binomials, we will use the FOIL method. The FOIL method is just a method for multiplying polynomials, only the binomials, in which you multiply the first ones. So these are the first ones. The outer ones, this is outside, this is outside. The inner ones, this is an inside, this is an inside. And the last terms, this is a last term, this is a last term. So we just need to make sure that we do those in that order, first, outer, inner, last, and combine everything to simplify it down. So, starting with this, our first one is to do the first. So 2p and 4p, which multiply to 8p squared. The next one that we want to do would be our outer pieces, 2p and 1. 2p times 1 gives us a 2p. The next piece we want to do is the inner, 3 and 4p. 3 times 4p is going to be 12p. And again, our last ones are the last, 3 and 1. 3 times 1 just leaves us with 3. Now looking at this, we have two different terms that are in terms of p. P to the first power, so those are the ones we need to combine. So we leave our 8p squared as it is. 2p plus 12p is going to give us 14p plus the 3 constant at the end. So in the end, our polynomial sums up to, or multiplies out to 8p squared plus 14p plus 3. Foiling out this second one, if we want to do our first, 5x and 5x become 25x squared. If we want to do our outer, that would be 5x and negative 4w. Remember, it has that negative out in front of it, so we need to do negative 20xw. Now if we do our inners, it's going to be 4w and 5x. That's going to give us a positive 20xw. And moving on to our last, 4w and negative 4w gives us negative 16x. Oops, not xw. There's no x in that one. That one is just negative 16w squared. Now again, from here, two terms have the xw as their variable, or their term. So those are the ones we need to combine. Our 25x squared stays as it is. The negative 20xw and the positive 20xw, those add together to make 0, so we can just get rid of those. That'd be, in the end, 0xw, so it's not necessarily right that. And then we're just left with negative 16w squared. So our simplified version of this polynomial is going to be 25x squared minus 16w squared. Moving along to our last example for the binomials, when we have a binomial, 2x minus 9 squared, this is not going to be the same as when we have our monomial squared. When we had the monomial squared, we would just take our exponent and we would apply it to each of our pieces individually, which in this case would have left us with 4x squared plus 81, because each of these pieces would have been squared. I'm going to tell you that that is not the case on this one. When we have, when we are squaring a binomial, we need to make sure that we put it in a FOILable form. So when we square something, that's the same as saying take your binomial and multiply it by itself. So we'd have to write 2x minus 9 times 2x minus 9. Now from here, we can FOIL it out and say our first ones, 2x and 2x, multiply together to become 4x squared. Then we take our outer, so 2x and negative 9, leaves us with negative 18x. Then our inner, our negative 9 and 2x, gives us another negative 18x. And now our last, That would be negative 9 and negative 9 gives us a positive 81. From here, two of our terms are just in terms of x, so we have to combine those ones. So in the end, we are left with 4x squared minus 36x, so we have the negative 18 and the negative 18, that subtracts to negative 36x plus 81. Now remember, like I said, if we just took the second power that is squared and applied it to each of those individually, that would have left us with 4x plus 81, but we would have missed the negative 36x part. So we need to make sure to always FOIL whenever we're using binomials. Moving on to multiplying polynomials. This is going to be similar to our FOILable format, only FOIL only works when it's binomials. When we're multiplying polynomials that are in terms that are bigger than binomials, so there's more than those two pieces, it's going to be similar in the sense that we're distributing each piece to each other piece. So in this case, we would have to distribute the a to each of our other terms, so a to the negative 4, a to this 3a, and a to this a squared. And we would have to distribute the 2 to our negative 4, our positive 3, or positive 3a, and our a squared. So there's going to be 6 pieces, whereas our FOIL just gave us 4, and then we simplified it down. So if we start with a and a squared, that's going to give us a cubed. And if we do a to 3a, that's going to give us positive 3a squared. And if we do a to negative 4, that's going to give us negative 4a. So now we've done all of them with the a. Now we need to go on to 2. So if we have 2 times a squared, it's going to give us positive 2a squared. 2 times 3a, that's going to give us positive 6a. And 2 times negative 4 is going to give us negative 8. Now from here, again, we need to combine terms. Our a cubed is the only one of its kind. Our 3a squared and our 2a squared can get combined. And our negative 4a and positive 6a can get combined. Negative 8 is the only constant we have. So once we find how to combine all of these, we just rewrite them out. So all of our a cubed terms are there, so just the a cubed. Now we need to put all of our a squared terms together. So 3a squared and 2a squared adds up to a 5a squared. So that were our a squared ones. Our negative 4a and our positive 6a, those add up to a positive 2a. And we still have our constant, is that negative 8. So in the end, our answer is just going to be a cubed plus 5a squared plus 2a minus 8. In the same way, if we look at this next one, again, we have a binomial being multiplied by a trinomial. We just need to remember to distribute each one individually. So our x to the x squared, x to negative 3xy, and x to the positive 2y squared, and the y to each of those individually. So if we start out by doing the x to the x squared gives us an x cubed. X to the negative 3xy gives us a negative 3x squared y, because of our two different x's being multiplied. And our x to our positive 2y is a positive 2xy squared. So that was the first part of that. Now we need to look at all of our y's. So if we have y times x squared, I'm actually going to move this over some. So if we have y times x squared is going to give us plus, well, I'll write x's first, so plus x squared y y times negative 3xy gives us a negative 3xy squared, and y times positive 2y squared gives us a positive 2y cubed. Now again, we're not finished until we have all of these ones simplified down by combining all the like terms. So here we see is all of our x cubed terms, so we can just write x cubed is all alone there. Here we have an x squared y term and an x squared y term, so we need to combine those. We have a negative 3x squared y and a positive 1 x squared y, so that becomes negative 2 x squared y. Moving on, we see that we have our xy squared term and our xy squared term. This one is a positive 2, this is a negative 3. So we add those together to get a minus 1, or just negative xy squared is our third term. And we just have one of our y cubed terms. So in the end, that just becomes positive 2y cubed. Oops, that's a cubed, not squared. So in the end, after adding them together and simplifying down, our answer is x cubed minus 2x squared y minus xy squared plus 2y cubed.